All right. Well, welcome back to another video. If you're here, I'm assuming you want to learn how to graph a line because the coffee's not great. That's the only joke I got, so I hope you laughed. It's going to be the only joke of the whole video. So today we're going to graph a line that's already in slope-intercept form. That's the best form when it comes to graphing. And so let me serve that up for you. There we go. I think got the music going, so hopefully you're ready to roll, as we like to say. So let me just give you a brief reminder that you're graphing a straight line. So in theory, all you need are 2 points. Because like you remember from geometry, 2 points define a line. I might graph 3 points because I'm feeling a little crazy. I might go for 3, but we'll see. First thing I want to show you is what it means to graph a line. So basically what happens is you're always going to start at B, then you're going to go over 1 and up M, whatever M is. This is how you would graph, like say y equals mx plus b, and that goes on for all eternity, and you connect these points and you get a straight line. So it's always over 1 up M, over 1 up M, over 1 up M. And you could kind of think of that M as being over 1 if you'd like. So we're just going to apply that theory to this equation, which is 3x plus 4. So in this case, you can see that M is equal to 3, and B is equal to 4. So we're going to start at 4. We're going to go over 1 and up 3, over 1 and up 3. So I'll make sure you can see this. I know this probably isn't super easy for you to see here, but we're going to go up to 4. That's there's 4. Now what I'm going to do is I'm going to go over 1, and every time I go over 1, I have to go up 3. So plus 1 and plus 3. Okay, now I'm going to go over 1 again, and I got to go up 3. So every time I go over 1, I'm going up 3. So it's looking, you could see it. You could say it's good enough. Once I have about 3 points, what I'm going to do is grab my ruler and say we are graphed. Okay, and that's the graph of 3x plus 4. Now your teacher often will use rise over run when they're graphing. So they'll say go up 3 and over 1. If you look at what happens, if you go up 3 and then over 1, that's exactly the same as going over 3 and up 1. So why would we care which one you do? I don't. I really don't care. I will always, and I do this with my classes, I always go over first and then up. And the reason I do that is because every equation is just a function, right? Like this is just a function. It has an input, which is the x, and it has an output, that is the y. And so with the function, what we do is we change the input and we see how it affects the output. So I say, okay, if I change the input by 1, the output goes up by 3. If I change the input by 1, the output goes up by 3. And so I'm always going to change x and then change y. It's also worth noting that slope itself, which is a measure of steepness, it's how we measure how steep this line is, would be 3 over 1. You write the 1 because when you divide by 1, it doesn't change the value of the thing you're dividing. But 3 over 1, that would kind of be your rise over your run. So a rise of 3 and a run of 1. But I would prefer perhaps you to think about it as that's how y is changing, and this is how x is changing. So the little triangle in mathematics stands for change in. So this says if you change x by +1, y must change by +3. All right, let's graph a different one. Let's go y equals -3x. Let's start in the same place. -3x plus 4. So right now, what I need you to do is I need you to hit pause and attempt to graph that. Pause. Unpause. All right, let's go get it. Actually, let's put on a little music here, see where the music's at. Oh, it's a little bit more chill now. Oh, that's it. All right, I guess it's time to relax. That's really nice, right? Backbone masses. All right, but either way, here we go. I'll do this one in green. So we're going to start in the same place. We're still going to start at 4. Okay, so there we are, starting at 4. Now, the slope is -3. So again, what that means is I'm going to go over 1, but this time I'm going to go down 3. Because remember, slope is a measure of how y changes over how x changes. So if I have -3 over 1, that means every time x gets bigger by 1, y is going to go down 3. X gets bigger by 1, y goes down 3. So I'm going to go over 1, and this time I got to go down 3. And go +1, I got to go down 1, 2, 3. Once I have 3 points, I'm pretty much stoked at that point. So I'll go here and holla. All right, so this is 3x plus 4, and this one is -3x plus 4. All right, let's go get one more. This time, let me clear the board a little bit for you. Perfect. So this is a little downtime where if I was a little bit more ambitious, I would edit this out. But this is some one-take business here. One take. So let's just get it going. Here we go. All right, good enough. And what we're gonna graph, sorry, I'm looking around, you're like, well, what's he looking for? He's looking for an eraser. All right. So let's go with y is equal to 2/3 x plus 1. All right. So, you know, sometimes you even think about ym and yb, like what's up with those names? I've heard math teachers say m because it's how it moves. I kind of like that, and I've heard b is kind of where it begins, so it's kind of a reason to use b and m. That's kind of cool, right? Because it begins when x equals 0. And if you plug in a 0 for x, it really doesn't matter what m is, because 0 times anything is 0, and y is equal to b. That is where y begins. So here, y is going to begin at 1. So I got a nice solid dot there at 1. This didn't shade in super good, but oh, there we go. Now we're rolling. And there's our x and y axis. Okay, so now I got to apply the slope, but this time the slope's a fraction. And this is, I swear, when you graph in lines, it's like the one time where fractions are probably make more sense than integers. This fraction is going to be really friendly, but before I do that, show you how friendly it is, I just want to remind you what I said earlier, is that you're always going to begin at b when the equation has this form, and you always go over 1 up m. That's every single line is defined the same way. If I go over 1, how far up do I need to go? Or if m's negative, How far down do I have to go? So in this case, you could, because m is 2/3, right? M is equal to 2/3. You could go over 1 up 2/3. Over 1 up 2/3. The problem is that when we're graphing by hand, we kind of like integers because we know exactly where they are. I don't know exactly where 2/3 is on a piece of graph paper, right? Over 1 up 2/3. So the trick here is to realize that if you go over 1 up 2/3, over 1 up 2/3, over 1 and up 2/3, well, what's 2/3 plus 2/3 plus 2/3? Well, you got to add that. That's 6/3, which is just 2. And so it turns out that going over 1 up 2/3, over 1 up 2/3, over 1 up 2/3, that you can just go over 3 and then up 2, and you'll be in the exact same place. The exact same place. I know what you're thinking. You're thinking like the exact same place, and I'm like the exact same place. And so when we have a slope that's a fraction, we don't, we no longer kind of use this rule of going over 1 up m, because we realize that if I just go over 3, then I can go up 2. And that's really beneficial when you're graphing because you get to stay connected to integers. So now that I'm here, what I'm going to do is I'm going to go over 3 and up 2. So that's a little plus 3 and plus 2 and put my next point. I'm psyched. I'm good. In fact, if I grab my ruler, I would be done, but I don't want to do that yet. I want to add a couple more points because I just figured this out. So now I'm feeling pretty good. And it's worth noting that essentially if x gets bigger by 3, y goes up by 2, which means if x gets smaller by 3, go back the other way, y's got to go down by 2. And notice we still have a beautiful straight line. And we are there. Okay. Gorgeous. So remember, when we have fractions, the slope is 2/3. But instead of going over 1 up 2/3, at this point we'll go over 3 up 2 because it makes it a lot easier to graph. All right, well, I think that's all I'm going to show on this video. Well, maybe real quick, let me do this one. And I wasn't going to do this one. I was only going to do 3, so this is a bonus track. If it's a bonus track, let's hit play. There it is, bonus track. Alright, what if it's a negative? Uh-oh. And let's go -2. What do you do now? That's a hell of a question. Alright, let's go get this real quick. First of all, we're going to start at -2, so I'm going to put a dot there at -2. As far as this slope, we could go over 1 and down 2/3. Right? I could go over 1 and down 2/3. That's possible because the slope is -2/3. But what's going to happen is that if I do that 3 times, I will have gone down 2. So the way we're going to read this, because it's a fraction, is I'm going to say the slope is the change in y over the change in x, which is -2/3. So every time x gets bigger by 3, I'm just going to make y go down by 2. So watch, and I'll put this one in green. I'm going to make x go up by 3, which is going to drive y down by 2. Every time x goes up by 3, drives y down by 2. So this +3 -2. And if we connect it here, we get this shape right there. it is, maybe lastly, a lot of times when it's printed, it looks like that, right? Where the negative sign doesn't look like it's on the 2 or the 3. At that point, you just have to pick. Now, I like to put the negative sign with the y because I like to make x positive. I like to go left to right. I like to say, okay, I'm going to go over 3 and I'm going to go down 2. But I could also have written it like that, which says if I go back 3, I need to go up 2, because these are, at the end of the day, equal. Alright, well that was a little bonus track. Always good to throw in a little bonus track, keep people on their toes. I hope you're having a wonderful day. I hope the sun is shining, or maybe it's not, I don't know. I gotta go. Let me know if you have any more questions, and have a beautiful day. Whoa, whoa, hey, get out of the camera. Get out of the camera, buddy. I got some coffee.
The mother's looking shy.
Gonna need it too.
Even though all the jokes